A prediction interval for a new observation is similar to, but very distinctly different than, the confidence interval for the mean response. Right? The dash dot dot dash line is the prediction interval for the new observation, and that's for a single point, as opposed to the curve that is the confidence interval for the mean response is a population parameter, right, an aggregate style response. So it's going to have a much tighter bound than we're going to have for the prediction interval. Right, so let's see how we actually develop these lines. And there is going to be some mathematical similarity, but the differences will turn out to be significant and, of course, cause the change in those lines that you saw. So our future observation we'll call y hat y naught, and it's occurring at x naught. Right? And a point estimator for that future prediction is just to evaluate the least squares line at x naught. Now the error that we're going to have there for the prediction, we'll give it a subscript of a p hat, and that's the difference here between y, the future observation, and the predicted value. And this error is also going to be normal, have a mean of 0, and the variance will be of some interest here for us in our prediction. Right, so that's really just the variance then of y naught minus y hat naught. And now the next crucial step is to realize that our prediction is based on the past, and we've done data collection on that. And so that's purely a function of what we've done in the past, whereas this new one is independent, right? Each and every one of the individual observations are independent of each other. So these two quantities then being independent mean that we don't have a covariance term, and so a variance of a difference is just going to be the sum of the individual variances, right? And because this is coming off the regression, this is the regression world, so this leftover unexplained variance here is going to be just sigma e squared for the y naught, and then for this one, that's going to be what we found just a minute ago with our confidence interval and the true mean. Right, and that obviously could have this factored out of it to make that a little bit simpler looking, right? And so let's go ahead and do that, but when we do that, we're going to go ahead and make our substitution that we're going to estimate with our standard deviation of the error. Oops. So I'm going to factor that out. So 1 plus 1 over n plus quantity x naught minus x bar squared over sxx. And there you see the big change that I kept talking about, that one value right there that's coming in. That's coming in from the predicted value. And so this is crucial here. As we make that step, we'll note that our t statistic then will be y naught minus y naught hat over this variance of our prediction value, and of course we want the standard deviation of it, right? And the mean is going to be 0, so we don't have to write minus 0. And that's going to have n minus 2 degrees of freedom that are associated with it. And so the interval itself will then be y naught hat plus or minus our t critical value, Right, so 95% two-sided, and with n minus 2 degrees of freedom, that number is 2.131 for our aquifer data. And then we'll take it times the standard deviation here, which I'm just going to write as the variance of the error for the prediction, and then the square root of it there to get that standard deviation, that same form. And remember, again, y hat naught is equal to the evaluation of the linear regression line at x naught. And that's going to give us then the spread that you see up in the chart. Right? And in this case, that 1 was dominating the expression more so than the other terms, more so than the 1 over n term, which becomes almost insignificant. And then so you really have the 1 term, and then you have the x naught minus x bar squared, the squared deviation away from our mean value of x. So how far away are we? And even that gets normalized by SXX, so it turns out to be relatively small, and that's why it would have the appearance for this prediction interval in this specific instance that almost seems parallel to our regression line. It isn't actually parallel, but here at this particular one on this particular scale, it would seem that way.